Hello, everyone, and good afternoon. My name is Adam. I'm here to talk about Wormhole and various exciting tokenization efforts that are going on in the background. So we're going to cover blockchain interoperability in general, at what Wormhole is, how it does what it does, in within the time constraints that we have, some common use cases, which most of you, I think, would be familiar with in general, and then two bespoke use cases that we are currently working on in the tokenization space. So let's jump into it. So blockchains in general, they are not able to communicate with each other by default, which is quite obvious, especially if they are on different runtimes. So we are not necessarily talking about EVM networks or Ethereum rollups and whatnot, but bespoke runtimes such as Algorand or SVM versus EVM, MoveVM, Sui, etc., etc. And it is quite challenging to pass messages between those blockchains. However, users prefer various blockchains over others for multiple reasons, such as security, general gas price, liquidity incentives all over the place, compliance when it comes to institutional integrators, or various business deals that protocols might have with different blockchains. And so the problem is very similar to what the SWIFT interbank system is aiming to solve. In fact, Wormhole's closest analog in the traditional space is actually SWIFT. So, yeah, blockchain interoperability is important to capture different user groups who are using different chains and to take advantage of different blockchains' comparative advantage and to scale your protocol to unlock new use cases that we'll get into. So Wormhole actually started out as a hackathon project, as a token bridge between Ethereum and Solana. And the protocol is now significantly more than that. We are currently in a stage of vastly improving the general user experience as opposed to previously where we were still working on the infrastructure layer to make sure that everything is running smoothly. And to just give you an idea of how Wormhole message passing works in general, there is a core contract deployed on every Wormhole integrated chain. And there is a set of 19 entities called the Wormhole Guardians, who are validator entities, including Triton, who is somewhere here, and many others, the biggest validator entities, who are running full nodes for each of the Wormhole integrated chains. They also validate most of these chains, but that's not necessarily a requirement to validate Wormhole itself. And they use those full nodes to watch events that are happening on this core contract and produce signed nodes, or basically a notary service to sign nodes, publish signed attestations, which we call VAAs, verifiable action approvals, which you can take and submit it to its intended target chain to achieve some effect. So maybe through an example would be much easier to understand. So let's say I want to transfer a token from Ethereum to Solana. What I would do is that I interact with, let's say, the Wormhole token bridge, and I lock my tokens in Ethereum. The Wormhole token bridge then publishes an event via the Wormhole core contract, which the Guardians then see. And each of them append their signature attesting to the fact that this thing actually has happened. And then you take that attestation, the VAA, and then you submit it to Solana, where another token bridge contract mints you a wrap representation of the tokens that you just bridged over from Ethereum. So very basic. And this was like the very first use case that Wormhole tackled. But the message itself doesn't necessarily have to be a token transfer. It can be any message that the integrator wants to use Wormhole for. And so there is a lot of applications that are built on top of this primitive. The token bridge was one example, and we're going to see a few other examples as well. So one of the basic ones, use cases, as DeFi applications can integrate Wormhole into their front end to make it easier for users to hop between chains. Then another use case which doesn't use token transfers, but instead generic message passing, would be governance, especially hub and spoke governance. For example, Uniswap's governance modules are on mainnet Ethereum, but Uniswap itself is deployed on many other EVM chains as well. So they had a problem of how do you make sure that governance decisions on Ethereum are actually propagated and taken into account on other chains. And the answer, as decided by Uniswap, was Wormhole. That the Wormhole Guardians see when a governance decision takes effect on Ethereum, and they produce VAAs for these decisions, which then the Uniswap team can pick up and submit to other chains to make sure that those decisions are propagated to everywhere else as well. Then we've already covered token transfers a little bit. And another interesting use case would be Oracle services. So many of you might be familiar with Pyth, which is a kind of a Solana native Oracle feed that also uses Wormhole to distribute the price feeds that they are collecting from various TradFi and other entities. Then, some custom integrations include bringing NFTs to cross-chain or migrating NFTs from a chain to another in a one-way manner, et cetera, and cross-chain borrow lend or natively multi-chain apps are also some of the more popular use cases. So now the interesting stuff. So when it comes to real-world assets, deploying a token and calling it a real-world asset is really easy. The problem becomes, how do you convince other people, or institutional players especially, that the token you had just deployed actually represents something of tangible value in the real world? And so the answer to that is by making sure that whatever system you come up with is as close to the existing legal framework as possible. So the institutional players are actually looking for these items, which we're going to go over one by one. So compliance, that's probably the biggest one. How do you design your system as an institutional player that you're compliant with whatever regulations you need to comply with in your region? Then a related concept is configurable permissioning or controls. So it's not necessarily the case that real-world assets as the on-chain entities should be fully permissionless. Integrators might actually desire this not to be the case to comply with existing regulations. Then obviously security. Institutional players take security really seriously. They don't want to be hacked, especially in a Web3 environment where you can't just roll back your database easily to make sure that the thing didn't happen. And then actor accountability is also an interesting one. So what would happen if, let's say the Wormhole Guardians would sign a fraudulent message and transfer some real-world tokens to a place where it wasn't supposed to go. And this is one of Wormhole's biggest selling points and why BlackRock and Securitize have chosen Wormhole as the interoperability provider, because the way that the message verification works over Wormhole makes sure that whoever has signed a potentially fraudulent message can be easily identified. This is the multi-signature scheme that the Wormhole Guardian network operates on. So in case there is a fraudulent message, you can see which of the Guardians have signed that one, and you can pretty much sue them out of existence because they are real-world entities who are also under the law, obviously. We have 5 minutes left, so let's talk about another interesting tokenization use case, in this case Dogecoin, which you might have seen in previous announcement that is going live at some point in the future over Wormhole. So when it comes to Dogecoin and when it comes to bringing Dogecoin to other chains, the challenge becomes, well, how do you even do it? Given that, Dogecoin, the chain, isn't Turing complete. It doesn't support smart contracts in a way that other more modern networks do. But there is a solution. Actually, it's a two-part solution. This is the first part. So getting Doge out of Dogecoin and, let's say, into Solana or into other Wormhole connected chains. And for this part, the solution is zero-knowledge proofs. So in the first bit, you would deposit your Dogecoin into a Doge address, which is controlled by an ECDSA threshold signature scheme by the same Wormhole guardians that I was referring to earlier. And then there is an off-chain service run by somebody that generates the ZK proof that this event really happened. And what's important that when the original user transferred their initial Doge tokens into that address, they can add their Solana pub key in that transaction, which then the off-chain service can pick up and take into account when generating the proof. And then you take that proof and you submit it to a Solana contract that means the tokens to the user's Solana address. So pretty easy. There is actually no Wormhole messaging, so the core primitive isn't actually needed for this. It's only a matter of ZK proof generation on Doge and submitting it to Solana. But the other way is a little bit trickier. So how do you get Doge back from let's say from Solana back into Doge to unlock your original tokens? So yeah, Doge, the chain is still not Turing complete. There is no smart contracts that would be able to do this easily. But given that in this setup, let's say the guardians would control the threshold keys for the original Doge deposit address, what you would do is that you burn your Doge tokens on Solana. And in that same transaction on Solana, it's pretty easy to add your Doge address in that transactions. And given that the Wormhole guardians are already integrating Solana and they are able to observe this event taking place, they can use their threshold keys to publish a transaction that then lets you submit that transaction on Doge to get your tokens back from the custody address into your Doge address that you specified on Solana. So that's basically the three-way step. Even in this, even the other way back, this isn't the traditional Wormhole messaging, the traditional Wormhole Guardian multi-signature messaging that I described in the first part, but this is a different verification scheme that is built on threshold signatures. There is another hugely popular blockchain from which Dogecoin was actually born of. So stay tuned for other types of assets that might be coming over Wormhole using this scheme. So just a little bit about integrator stuff on what you might use to make your lives easier if you want to use Wormhole to do anything cross-chain really. We've got the application layer, for which I want to highlight three things in general. We've got the Wormhole Connect front-end widget that's basically a plug-and-play thing that you can embed into your front-end application and get out-of-the-box token transfer support for mostly all of the Wormhole integrated chains with just a few lines of code. And it doesn't just support one type of token transfer, so not just Wormhole token bridge tokens. It also supports NTT native token transfers. It also supports CCTP transfers, which is totally independent of Wormhole, et cetera, et cetera. Then if you want to go one layer deeper, then we've got the SDK to do pretty much everything and more that Wormhole Connect is able to do. Plus, we've also got a recently launched settlement layer on Solana that is powerful enough to facilitate any-to-any token swaps between Solana and any of the compatible EVM chains. And then we are almost out of time, so I'm not going to go very deep into the other stuff. We've covered them, almost all of them, in any case. So if you have any questions, then feel free to reach out, feel free to scan that, and thanks everyone.